Geometric sequences, example 2. In a geometric sequence, T3, so term 3, is equal to 32, and T6, so term 6, is equal to 4. Find A and or, and hence, so using what you've just found out, write down the first 6 terms of the sequence. So our Tn formula for a geometric sequence is A multiplied by or to the power of n minus 1. Now in your formula book, the A and the or are stuck together. It means the exact same thing. So we're told that term 3 is equal to 32. So we're going to start off using term 3. We'll come back to the 32 part in a minute. So Tn becomes T3 and the n in the power becomes 3. So we have T3 equals A times or to the power of 3 minus 1. We're going to replace T3 with 32 because we were told that T3 is equal to 32. And then 3 minus 1 is 2. So our power is 2. So just to note, that's where the 32 came from. It came from the question. I've highlighted it there in yellow. And then A times or squared is just A or squared. So we've just simplified. So now we have an equation in terms of A and or. And remember, that's what we're trying to find. We're trying to find A and or. So we can't find them at the moment because we have one equation containing 2 unknowns. So we're going to use the next piece of information, which is T6 is equal to 4, to create another equation in terms of A and or, and then we can solve simultaneously. So again, we start with our formula. Tn is equal to A times or to the power of n minus 1. So term 6 is equal to A times or to the power of 6 minus 1, replacing the n with 6. And the reason we've chosen term 6 is because it's given to us in the question. We'll come back to the 4 part now in a second. So we replace term 6 with 4 because we're told in the question that term 6 is equal to 4. And then 6 minus 1 is 5. So I've just highlighted there where the T6 is equal to 4, so where that came from. So we have 4 is equal to A or to the power of 5. So now we have a second equation in terms of A and or. And that's what we're trying to work out. We're trying to work out A and we're trying to work out or. So we're going to use this equation, 32 equals A or squared. And we're going to use this equation, 4 equals A or to the power of 5, to work out A and or. And once we have A and or, then we can figure out the first 6 terms. So we're going to divide the terms with the highest power on top. So A or to the power of 5. So the 5 is bigger than 2 in terms of powers. So A or to the power of 5 is our numerator, and A or to the power of 2 is our denominator. And that's equal to 4 over 32. So our second equation that we worked out in terms of A and or was 4 equals A or to the power of 5. So they go on top, purely because the 5 is bigger than 2, the other power. And then 32 equals A or squared. They go on the bottom, so they're the denominators. So why can we do this? So let's say x is equal to 4. So this is just an example to show why we can actually do this. And then I'm going to come back to this in a second and actually work it out. But I just want to explain why we can actually do this, why we can put our equations into fractions and let them equal to each other. So let's say x is equal to 4. Then x squared would be equal to 16 because 4 squared is 16. And x to the power of 5 would be equal to 1024 because 4 to the power of 5 is equal to 1024. So if we put the highest power on top, so x to the power of 5, and we divide it by the lower power, which is x to the power of 2, and then we equal them to the fractions of what they were equal to in the original equation. So x to the power of 5 is equal to 1024, so they become the numerators. And x to the power of 2 equal to 16, so that becomes the denominators. So the main thing to do is make sure that the highest power is on top. So whatever the highest power is, that goes as the numerator. And then whatever that was equal to goes as the other numerator on the other side of the equals. And then likewise for the denominator, the lower power is the first denominator on the left-hand side, and whatever that was equal to is the denominator on the right-hand side. So just to show in yellow and green how it matches up with the equation that we're working with in terms of A and OR. So I'm going to come back to this in a minute, just focus on this, but the yellow parts obviously represent the yellow parts and the blue parts represent the blue parts. So it's just to show the similarities. So x to the power of 5 divided by x to the power of 2 is x to the power of 3, because 5 take away 2 is 3, and dividing powers with the same base, we subtract the powers. And then inputting into the calculator, 1024 divided by 16 is 64. And x to the power of 3 equal to 64. If we want to solve for x, then the cubed comes over the equal sign and becomes the cube root. So x is equal to the cube root of 64. And the cube root of 64 is 4. So x is equal to 4. And that's what we started off with. So this works. So putting the highest power of x as a numerator and dividing by the lower power of x, so letting that be the denominator, and then putting whatever we had the highest power of x equal to as the numerator on the right hand side, and whatever we had equal to the lower power as the denominator on the right hand side, we can use this format, or it's not so much a formula, more so as a rule, but we can use this rule to solve for x, and we can clearly see that it makes sense. X does equal to 4. So you can try this out with lots of different numbers if you want. So like, let's say x squared equals 16 instead. If you wanted to do x cubed, x to the power of 6, work out what any of those values are, and then set up some algebraic fractions, and then solve for x, and you should get back to the start again. Whatever you let x be, you should get back to the start. So it's just an example to show why this statement works. So a or to the power of 5 divided by a or squared is going to be equal to 4 over 32, because we worked out when we were setting up our equations using the information given in the question, we worked out that a or to the power of 5 is equal to 4 and a or squared is equal to 32. So we can set them up like this. So going back to this question now, so everything on the left-hand side is just an example to show why this statement makes sense, or why this rule makes sense. Okay, so just again, the numerators came from here. 4 is equal to a or to the power of 5. And the denominators came from here. 32 is equal to a or squared. Okay, so cancelling the a's. So the a's will just divide. And cancelling the a's, we're left with or to the power of 5 divided by or to the power of 2, which is or to the power of 3. Because 5 take away 2 is 3. And 4 over 32 into your calculator gives you 1 over 8. So or cubed is equal to 1 over 8. So or is equal to the cube root of 1 over 8. And that's equal to a half. So the common ratio is a half. Now, it's just a coincidence that we got the cube root here, and in the previous example, it won't always necessarily be the cube root. It obviously depends on what these numbers are. Okay, so if this was like, say, 10 and 4, then it would be the 6th root. If this was 5 and 3, it would be the square root, and so on. Okay, so or is equal to a half, so the common ratio is a half. So we were asked to find a and find or, and hence write down the first 6 terms of the sequence. So a or squared is equal to 32, so we worked that out on previous slides. So replacing the or with a half, because we know now that the common ratio is a half, we have a times a half squared is equal to 32. A half squared is a quarter, so if a times a quarter equals 32. So we get a quarter a equals 32, and dividing both sides by a quarter to solve for a, we get a is equal to 128. So we were asked to find a and find or. We found a to be 128, and we found or to be a half. So we're going to use that to work out the first 6 terms of the sequence. Hence is a really important word in maths, because it means using what you've just worked out to find the next part. So the sequence is, so 128, so we're starting with 128 because that's A. And then we multiply that by a half, or you could say you divide by 2 to get 64. Then multiplying by a half again, you get 32. Multiplying by a half, you get 16. Then 8 and 4, ... So here we have the first 6 terms of the sequence using A and OR to work them out.